Hi there, Mr. Sutton with another lesson on ellipses. In this one, we're going to learn how to write equations of ellipses given some combination of vertices, co-vertices, and foci. For your warm-up, because we're writing equations of ellipses, see if you can write the standard form of an ellipse for each of these major axes. All right, let's see how you did. So for x, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. For y-axis, major axis, we just have the same stuff, but a squared and b squared are switched. Let's dive right in now and find the equation of an ellipse centered at the origin with the following vertex and focus. First thing we should do is identify what the major axis is going to be. And if you're not sure, the vertex and the focus are going to be different from the center for that coordinate. In this case, since the center is the origin, the only thing that's not 0 is going to tell us what the major axis is. So in this case, that's going to be y, because the y value is what changed for each of these. Next step, we're going to use the vertex to find the a squared. We're going to need that for our formula. So in this case, our vertex is 13 away from the center of the origin. So we've got 13 squared, which gives us 169 for the a squared. Next, we're going to use, we need the b value eventually, but we don't have it, so we're going to use the focus instead to get the c squared. So that's going to be 5 squared, which gives us 25. And then, using a squared and c squared, you can use your b squared equals a squared minus c squared formula to find b squared, if they didn't give it to you directly already. So we've got 169 minus 25. That's going to give us a b squared value of 144. Well, we've got everything we need. We just have to write the correct formula now, plug in a squared and b squared. We also have to plug in h and k, but since the origin is the center of this thing, we're just going to have x squared and y squared for an h and k value of 0. So because this is major axis y, a squared has to be under y squared here. So we're going to have x squared over the b squared value of 144 plus y squared over 169 equals 1. For this next problem, we're finding an equation of ellipse given a vertex and a co-vertex. Pause the video and see if you can figure this one out on your own. All right, so for this one, we're looking at our vertex for the major axis. That's y got changed again, so major axis y. So we again have to square this to get our a squared. Squaring the vertex, that's going to give us 25. Now to get the b value, in this case, the b value just tells you how far it is from the center to the co-vertex. And since you know the origin is the center, that's a distance of 2, so you just have to square 2 to get b squared. So if they give you the co-vertex, you can get that pretty quickly. So that's 4. Now major axis y, again we have y squared with the a squared under it. So we're going to have x squared over 4 plus y squared over 25. We'll do one more of these. Pause the video and try it out. So for this one, because our focus changes the x value here from the center origin, that means we have major axis x for the first time in this lesson. And what else do they give us? A co-vertex. So that's going to give us our b squared. So we can do 6 squared for b squared, which gives us 36. We still need the a squared, but they did not give us the vertex this time. So we're going to have to use c squared and b squared together to find a squared. Well, what's c squared? That's going to be radical 13 squared, which is just 13. Now to find a squared if you have b squared and c squared, normally b squared equals a squared minus c squared. So if you add b squared and c squared together, you will get a squared. So that's going to be 36 plus 13, which comes out to 49. Major axis x, so we're going to have x squared over a squared this time. A again goes under the major axis variable, and then y squared this time is going to have the b squared underneath. So x squared over 49 plus y squared over 36 equals 1. Well, that's it for ellipses. Until next time, this is Mr. Sutton signing off.